Okay, guys, so we're going to go through significant figures in this lesson. Now, we're not going to be adding and subtracting, multiplying, and dividing using significant figures. I just want to make sure that we know the rules, okay? So, a significant figure is a number that compromises all the digits known with certainty plus one digit of uncertainty. It's how we predict measurements based upon how accurate or how precise we're measuring, okay? So the first rule is all non-zero digits are significant. So in this example right here, 11.21. Everything in that is non-zero, so they're all significant. Anytime zeros are sandwiched in between two non-zero digits, those are also significant. So the 1 and the 6 are non-zeros, and all these zeros in between are significant because of rule number 2. So this one has 5 significant figures. Okay, zeros to the right of a non-zero but to the left of an understood decimal point are not significant unless specified. Okay, so this is a tricky one. So the 1 and the 9 are significant and the 0 is not significant. Is significant because of rule number 2. Now, these zeros, this is the understood decimal point right here. It says that zeros to the right of a non-zero, so these are all to the right, but to the left of the understood decimal point are not significant unless specified. So the difference between this example and this example is this has the decimal point. Okay, so this has 3 significant figures and this one would have 6. 1, 2, 3, 4, 5, 6. Okay, all zeros to the right of a decimal point but to the left of a non-zero are not significant. So these are to the right of the decimal point but to the left of the non-zero. So these zeros are not significant right there. So this only has 3. Same thing here. This 0 is to the right of the decimal point but to the left of a non-zero. So this has 2 significant digits. All zeros to the right of a decimal point and to the right of a non-zero are significant. Okay, so this by rule number 4 is not significant. 4 and 3 are significant. The 0 in between is significant because of rule number 2. And this 0, because of rule number 5, is significant. So it has 1, 2, 3, 4. And then all of these zeros in this next example, those are to the right of the decimal and to the right of a non-zero. So they're significant. So that has 5. Now, I'm going to make these rules super easy for you. If you convert it to scientific notation, like we did in the last couple lessons, you can tell the number of significant digits. Okay, so let's take this one without having to remember any of the rules. So, if I move my decimal place over and I convert it to scientific notation. Okay, so if I move it to the right, it's going to be a negative exponent. So I'm simply just going to count how many digits do I have? 1, 2, 3, 4, 5. This is 5 significant figures. Okay, next example. We're going to move it 1, 2, 3. So it's 1.00569 times 10 to the negative 3. So this has 1, 2, 3, 4, 5, 6 significant figures. Okay, all of these are non-zero, so it's 4, or you can go ahead and convert it to scientific notation just for practice. 1, 2, 3 this way. So it's 2.589. If I move to the left, it's going to be a positive exponent. Okay, so I count my digits. 1, 2, 3, 4. Okay, this one, okay, so our decimal point is right here, correct? So we're going to move it 1, 2, 3 places to the left. And since I moved it to the left, it's going to be a positive exponent, so I'm going to count my digits. I have 1, 2, 3, 4, 5, 6 significant figures. Okay. These two are, this one's already in scientific notation, so I just count 1, 2, 3, 4. Okay, last one. We're going to move the decimal place over to the right, so we get 1, 2 places. So it's 5.31007 times 10 to the negative 2. Okay, so I have 1, 2, 3, 4, 5, 6 significant figures. Okay, so pretty much all you have to do is convert to scientific notation. Now, what I want you to do is I need you to work on this worksheet real quick. It should take you maybe 5 minutes tops to get these answers done. I'm going to fly through these answers real quick so you can check your work. Okay, so number 1 has 4 significant figures because they're all non-zeros. Number 2 has 5. Okay, that 0 in the middle is sandwiched. Number 3 has 3 significant figures. Number 4 has 4 significant figures because they're all non-zeros. If I convert this, it's 1.89 times 10 to the negative 1, so it's 3 significant figures. This should have, what do we do? So it should be 5 significant figures. These are all non-zeros. It's 3. This should be 2.35 times 10 to the 1, 2, 3, 4, negative 4. So they should have 3 significant figures. Same question again. Don't know how that happened. 3 significant figures. All non-zeros, 3 significant figures. Okay, this is one of those tricky ones. The decimal place is understood to be right here, but I think it's rule number 3 that says if the decimal place isn't given, those 2 zeros are not significant. So this is 2 significant figures. All of these are significant in this one, rule number 3. These are in scientific notation, so you just count. 1, 2, 3. Same thing here, 1, 2, 3. This should be 4, 7 significant figures because they're all non-zeros. 1, 2, 3, 4, 5. This one's 5 significant figures. They're all non-zeros. I'm going to convert this one to scientific notation. Okay, so it should be 4 significant figures. These are to the right of the 0 and to the right of the non-zeros. I mean, to the right of the decimal place and to the right of the non-zeros, so they're significant. This should be 4 significant figures. We just count them if it's in scientific notation. This should be 3. And this should be 1, 2, 3, 4. Okay, so hopefully you got all these right. And if you have any questions on how I arrived at the answers, feel free to reach out. You're probably most people miss this one and this one. Okay, so this is going to go with rule number 3. So look back at that example for rule number 3. If you have any questions, feel free to reach out. Thanks, and have a great day.